as x approaches infinity of this x squared plus 1 all on 3x cubed minus 4x plus 5 minus 4x plus 5 plus 5 if it exists. If this whole function would exist. So how would we treat this? The limit as x approaches infinity of this x squared plus 1 all on 3x cubed minus 4x plus 5. I believe you've done rational functions, so we can know that the highest power here is 3 and the highest power here is 2, right? This one is greater than that. So this one, we call this one a proper rational function. I believe you can recall a proper rational function. This one is a proper rational function because the degree here of this variable here is 2 and the degree here of this variable here is 3. After this 3, the highest power is 2. But because of this 3, this one is never true to be what? The highest power, right? So now, how should we do this? So I said, when you get a question of this nature, as x is approaching a larger number, how will you do that? What will be the limiting value of this function? So I said you divide the numerator, each value or each variable in the numerator, you divide it by what? The highest power. And the denominator, each value there, or each variable, you divide it by the highest power. So now we move as that. So I get the limit as x approaches infinity of x squared all over what? S cubed plus 1 over what? S cubed all on 3x cubed all over s cubed minus 4x on x cubed plus 5 all over s cubed. So this is how it goes. This is how it moves. So we have this. The limit as x approaches infinity of this x squared over s cubed plus 1 over s cubed all over 3x cubed all over s cubed minus 4x all over s cubed plus 5 all over s cubed. So you can see that I'm dividing, this is the numerator, the whole of this is the numerator, but the numerator we have what? Terms. So I'm dividing each term by the highest power of what? The variable, the highest power, which is x cubed of this variable, the degree, the highest degree there. So you divide each of them. So now we still have the limit as x approaches infinity of x squared over x cubed. The whole of this x squared cancels 2 of this x. So we get 1 on x, right? So we get 1 on x. Then plus 1 over x cubed, right? All over. Now the whole of this cancels that. So we get what? 3 here plus, is it plus? Minus, right? Sorry, minus. Now this x takes 1 of this 3 x's here, right? So we get 4 on x squared. 4 all over x squared. Then plus 5 on what? X cubed. Plus 5 x cubed. So now, let's see. So we have the limit as x approaches infinity of this 1 on x plus 1 over x cubed, right? So you take the numerator, then you take the denominator. All on the limit as x approaches infinity of 3 minus 4 on x squared plus 5 on x cubed. So as that. Then we'll take the limit applied to it to each term. So we have the limit as x approaches infinity, right, of 1 on x, then plus the limit as x approaches infinity of 1 over x, all over the limit as x approaches infinity of 3, right, of this 3, then minus the limit as x approaches infinity of what, 4 on x squared, plus the limit as x approaches infinity of what, 5 on x cubed. So this is how it applies here. So when you begin to understand these things, you will not be doing this all. Because this one is good though. Some mathematics teachers want step by step like this. It's good though. It's good. But when you understand it, you can just go straight forward. That you know that here is 0, here is 0. He'll give you 3. Here is 0, here is 0. So you know what is going on. You know what is going on. So I believe I can clean this place. So we have it as that. So the limit as x approaches infinity, all on what? Of what? 1 on x, which is what? 0, right? Plus, I believe you know why it is 0. I explained, right? So plus this one to x to the power 3 is an exponential function. And when you place in a larger number, this function tends to what? 0. All on. Now the limit of what? A constant value as x approaches infinity is the same thing as what? The constant, which is 3, minus the limit as x approaches infinity on what? All of what? Of 4 all on what? X squared. You get what? 0. Then plus the limit as x approaches infinity of 5 on x cubed. We get what? 0. Because here is what? X cubed. Here is x squared. An exponential function here. So the function will tend to 0. So we have 0 plus 0, which is 0. All on 3 minus 0 plus 0, which is what? 3. So we get 0 divided by 3, which is what? 0. 0 divided by 3 is 0. So that's that. Very simple. Very simple. All right. So you can go through and see. So now let's see the next example here. Then I give you some to try. I'll give you one to try. So exercises to try, then move on to the next step. Alright. We are still on the subtopic limits of a function at infinity. Right. So we said find the limits as x approaches infinity, as x approaches a larger value of the function x cubed plus 1 all over 3x cubed minus 4x plus 5 if the so-called function, if it exists, right? If it exists. So now let's see. So we have this. I said you divide the numerator and the denominator by what? The highest what? Power, right? By the highest power here. So we have the limit as x approaches infinity of what's the highest power? It's x cubed, right? So I divide here x cubed all on x cubed plus 1 all on what? X cubed all over 3x cubed all over x cubed minus 4x all over x cubed plus 5 all over x cubed. So we have this. We have this. We have this. We have that. So we have this. So the limit as x approaches infinity. So we have this. The limit as x approaches infinity of x cubed divided by x cubed, you all know that is what? 1. Then plus, we have 1 on what? X cubed all over. This one cancels that. So we get what? 3 minus. Now this x is to the power 1 and this is x to the power 3. So it takes one of these x's, right? So here leaves what? X to the power 2. So I have minus 4 on x to the power 2, then plus 5 on x cubed. 5 on x cubed. So this. So we take the limit for the numerator and the denominator. So I have the limit, right? The limit of what? As x approaches infinity of 1 plus 1 over x cubed all over the limit as x approaches infinity of what? 3 minus 4 on x squared plus 5 on x cubed. So we have this, right? So numerator, I can treat it as the limit as x approaches infinity of 1. Then plus the limit as x approaches infinity of what? 1 on x cubed all over the limit as x approaches infinity of 3, right? Minus the limit as x approaches infinity of 4 on x squared, then plus the limit as x approaches infinity of 5 on x cubed. We have this. We have this. So I can put in here. So you can see that limits, they are very, very simple. They are not difficult like that. So at infinity, very, very simple. The limit as x approaches infinity of 1 is the same thing as what? It's the same thing as 1, right? Then plus the limit as x approaches infinity of what? 1 over x to the power 3. This one is an exponential function. So when you insert or when you plug in a larger value, this function goes towards 0. All on the limit as x approaches infinity of 3. The answer is still 3. Minus the limit as x approaches infinity of 4 on x squared. This one, the denominator is an exponential. So this function tends towards 0. And this one to the same thing. I believe you can see. So plus 0. So we have 1 plus 0, which is what? 1. All on 3 minus 0 plus 0 is 3. So this one is the limiting value, which is L. That's the limiting value. 1 on 3. 1 on 3. So I'll give you questions to solve. I'll give you questions to try your hands on. Can you try your hands on so that you'll be okay with that? Can you try your hands on so that you'll be okay? You'll be fine with that. Okay. So I'll give you simple ones. I'll give you difficult ones too, as well. So I believe you understand it. If you don't understand it, you are. Let me. Right. Okay. So we are done with a limit of a function at what? Infinity. We are not done with limits of a function, but we are done with this limit of a function at infinity. We move on to what? Limits of a function at a point. At a point. At a point. Limit of a function at a point. Now, this x value will no longer be what? A larger number, but it will be what? A certain value. This one will not take a larger number. We will take, let's say, negative 1, 2, 4. So how do we find the limit of that function? So let me give you exercise to try your hands on. Let me give you exercise to try your hands on. So let's see this exercise. Let's see this exercise. So that's home link, right? Or homework. Your assignment, try them. Numero N. We have the limit as x approaches infinity of 1 over square root of x minus 1. So how will you tackle this? So the question says, for each of the following, find the limits if it exists. So if it exists, you find the limits of that. Then 2, the limit as x approaches infinity of x, this squared, x squared plus 9 all on. So all on x squared plus 1, x squared plus 1, then 3, the limit as x approaches infinity of x squared plus 9 all on x cubed plus 1, and 4, find the limit as x approaches infinity of 5 to the power negative x, of 5 to the power negative x. Then 5, you find for the limit as x approaches infinity of 15 minus 16 x to the power negative 3. That's that. So you have the sit 1. You have the sit 1. The limit as x approaches infinity of 2x minus 1, of 2x minus 1 all over x plus 1, x plus 1, then 7. The limit as x approaches infinity of 4x plus 3 all over 3x plus 5. You find for the limit as x approaches infinity of 3x squared minus 2x plus 1 all over 2x squared plus 5x minus 7. So you try that. Try that. So this is the work. So you can pause the video, then you copy the work, right? So let me give you one challenge problem to try. One challenge problem under this. So it's a challenge problem. You try the challenge problem. So one challenge problem. It reads as what? You listen and write. The concentration You're a chemistry student, so you understand. The concentration C of a drug in a patient's bloodstream. So the concentration of a drug in a patient's bloodstream, T ounce, after it was injected, is given by, again, the concentration C of a drug in a patient's bloodstream, T hours, after it was injected, is given by, so let's see, is given by C of T. So the function C is in terms of what? T. So C of T is equal to what? 0.15 T all on T squared plus 3. T squared plus 3. So it's given by this. The function is in terms of what? T. So we have the function 0.15 T all on T squared plus 3. The A part of the question says, find the limit as T approaches infinity of the function Z of T. So you find the limit as T approaches infinity of the function Z of T. Then the last part, the B, says interpret the results in A. So you have to interpret the results in A. 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 You have to interpret the results in A. So that brings to an end of limits of a function at infinity. So we are still on limits of functions, but we are done with what? The first subtopic, which is what? Limits of a function at infinity. So you can go on and try more questions on limits of a function at infinity. So I've given you 8 examples, then plus this challenge problem. So you try them at your comfort zone, man. Alright. So we'll meet next time, then we tackle the next sub topic and the limits of the function. Thank you.